Hey guys, so here is the video to correct the homework on page 402, questions 9 to 17. I won't draw them out, okay, because it's going to take me ages to do that. I'll just go through the questions. So question 9 first. Question 9 says a cylinder has a height of 4.5 centimeters, okay, and a length of 2 centimeters. Do you know what? I will draw it. Makes it easier. Okay, a height of 4.5 centimeters and a radius of 2. And this is the same volume as a hemisphere. Okay. Find the radius of the hemisphere. Okay, so what we do here is we will put in the formula for both, the volume formula. So the volume formula for cylinder is pi r squared h, and that equals volume of a hemisphere. Well, volume of a sphere is 4/3 pi r cubed, but it's a hemisphere, so we divide it by 2. And an easy way, just if we're dividing by 2, instead of the 4 on top as the numerator, we put a 2 on top. Okay, fill in what we know then. We know everything on the cylinder side, we don't know anything on the hemisphere side, so fill that in. So it's pi, r squared is 4 squared, r squared is 2 squared, which is 4, multiplied by the height, which is 4.5, equals 2/3 multiplied by pi multiplied by the radius cubed. And this radius is not the same as this radius, okay, so we can't just put in 4. Okay, right, so figure out what we know. Well, I'll multiply the 4 by the 4.5 anyway. So 4 multiplied by 4.5 equals 18. So it's pi multiplied by 18 equals 2/3 multiplied by pi multiplied by the radius cubed. Right, so we have an equation, one unknown. Here's the unknown here, the radius. So we cancel the pi's, or another way of saying it, divide by pi on both sides. We have 2/3 multiplying over here, so I want to get rid of that, so I'll divide by 2/3, divide by 2/3, so 18 divided by 2 3 equals 27, and that's right, okay, because we're dividing by a fraction that's less than 1, so it's going to make the 18 increase. So radius cubed is 27, so we need to get the cube root of this side, and then we need to get the cube root of this side. So radius cubed and cube root of that is just the radius, and 27 cubed root of 27 is 3, so the radius is 3. Okay, that's question 9. Question 10. A basketball fits exactly into a cube which has equal sides and length to the diameter of the basketball. What percentage of the cube's volume does the basketball occupy? Use the pi key on your calculator to give your answer correct to the nearest whole number. Okay. Right. So as you can see, there's no real numbers in this question. Okay. And we could do this question with no numbers. We could just use a variable, x or y or whatever. But for simplicity's sake, I'm going to use a number. Right? I'm just going to make one up at the top of my head. So what I mean by that is we have this ball in the center. Now I am going to pretend that this is, I'll make it a small number. This is 2. Okay, so this side is 2, which means this is 2 and this is 2. Therefore, if that's 2, then the radius halfway here of the sphere must be 1. Okay. Now we're dealing with ratios, so even if this was 4 and this was 4 and this was 4 and that was 2, okay, it would still work. We'd still get the same answer. Okay. So let's figure out the cube. So the cube will be 2 multiplied by 2 multiplied by 2, which will give us 8 centimeters cubed. That's the cube. And the sphere would be 4/3 volume equals 4/3 pi r cubed. Volume equals 4/3 multiplied by, and they asked us to type the pi letter into our calculator, so we'll do that. Multiplied by the radius cubed. Well, 1 cubed is just 1. So volume equals, and we'll type this into the calculator. And when I do type that into the calculator, I get 4.18879. Yeah, I'll leave it at that. There is more. Okay. So I want the percentage. Okay, so I'll first put it as a fraction. So 4.18879 all over 8. 4.18879 divided by 8 equals 0.5235987.5, which will be 52%. Okay. Right. Next question. Question 11. When a solid sphere of radius 6 centimeters is dropped into a cylinder, partly filled with water, the level of water rises. It rises by h. That's shown on the right. If the diameter of the cylinder is 16, find the value of h. Okay. So water is up a certain level, gets dropped in, water rises by whatever level this is. There's our sphere. The sphere has a radius of 6. The cylinder has a radius of 16. I'm not interested in the rest of the cylinder. All I'm interested in is this, because the volume of this bit there rose and the volume of this are the same. So let's take this out here and let's take this bit out here. Now we have a piece of a cylinder, or an actual cylinder, and a sphere that equal each other. If the volume is equal, I'll use the volume formula. So 4/3 pi r cubed will equal pi r squared h. Fill in what I know over here. So 4/3 multiplied by, leave pi as it is because we know they cancel, and we know that the radius is 6, so it'll be 6 cubed equals pi multiplied by, the radius on this is 16, we were told, so 16 squared multiplied by h, which we don't know. We have, well, first thing we'll do is we'll square out or cube out our numbers. So 4/3 multiplied by pi multiplied by 6 cubed, which is 216, equals pi multiplied by 16 squared, is 256, multiplied by the h. We have an equation now with one unknown, and that unknown is our h. Okay. So the pi's will cancel, or another way of saying it, divide by pi on both sides. This 4/3, we need to get rid of that, so I'll divide by 4/3 on this side, and I'll divide by 4/3 on this side. Divide by 4/3 on this side, and I'll just be left with 216. Divide by 4/3 on this side, and I'll be left with that will give us 192 multiplied by h. And the last thing we do, we want to get rid of this 192, so divide by 192 on both sides. So it's 216 divided by 192 equals 1.125 equals h. So what are we asked? We're asked to find the value of h, which is the height that it's risen. So the h is 1.125 centimeters. Okay, so that's question 11 done. Right, question 12. Question 12, we have tennis balls. 3 of them in the cylinder, and they fit perfectly into it. And the diameter the whole way across is 6, which means the radius of the sphere equals 3, and the radius of the cylinder must be 3 also. Okay. So we're asked to find the volume of the tennis ball. That should be pretty easy. Volume equals 4/3 pi r cubed. So put in what we know, volume equals 4/3 multiplied by pi. We're asked to give our answer in pi, so we leave pi as it is. Multiplied by 3 cubed. Volume equals 4/3 multiplied by pi multiplied by 27. And 4/3 of 27 is what is that? 36. So 36 multiplied by pi. We're asked to give our answer as pi, so we will just say 36 pi, and of course centimeters cubed. Okay. We'll do the same for the cylinder. Let's draw the cylinder here. We know the radius is 3. Now what about the height? We know that the diameter of the sphere is 6. So that means from here to here is 6, and then here to here is 6, and then here to here is 6. So 6 plus 6 plus 6, and 6 plus 6 plus 6 is 18. So the height of this is 18. So volume equals pi r squared h. Put in the 18 here, put in the radius here. I'm not going to do it out for you because you should be well able to do that at this stage. You should get 162 pi centimeters squared. And the last bit of that question, they want to find out the volume of the cylinder that can't be occupied by those 3 balls. Okay, so 3 balls fit in there, and they're each 36 pi. So multiplied by 3, we get the volume of those 3 balls. So 36 multiplied by 3 is 108 pi centimeters cubed. So that's the volume of all 3 balls. The volume of the cylinder is that. So if we take one from the other, 162 minus 108 equals 54 pi centimeters cubed. Okay. Okay, next question then. A sphere with a radius of 3, so here it is, has a volume equal to 8 times the volume of a sphere with radius, whatever. Okay, so redraw that. Here's our sphere radius 3, and that has a volume 8 times the size of this, and we don't know the radius of that. Okay, but we could easily find it. If we find the radius of this and then divide it by 8, it'll give us the radius of this. Okay, so let's do that. So volume equals 4/3 pi r cubed, and that is volume equals 4/3 pi 3 cubed, and this will give us 36 pi centimeters cubed. That's the volume of that. I'll leave it as pi. Just see what they ask for. No, okay, we'll leave it at pi for the minute. Now, if I divide that by 8, alright, so divide that by 8, and I will get 36 divided by 8 is 4.5 pi centimeters cubed. You could, work out the pi, okay, and just deal with numbers, but I just think it's going to be easier this way. Right, so now that means the volume of that is 4.5 pi. So watch this. Volume equals 4/3 pi r cubed. That's for the small one, okay, this one up here. But I know the volume already. I put it in here. 4.5 pi equals 4/3 multiplied by pi multiplied by the radius, which I don't know, cubed. Now this is why I left that as pi, because I knew there'd be another pi over here and I could just cancel them. So we have 4.5 equals 4/3 multiplied by the radius cubed. If I divide by 4/3 on both sides, I get 4.5. We divide that on that side, we get 3.375 equals r cubed, and we need to get the cubed root of that. So on our calculators, the cubed root of 3.375 equals 1.5. So the radius of the small one is 1.5 centimeters. Okay. Question 14. The height of a cylinder is equal to the length of its diameter. Okay. Right. So this is a bit trickier. Right. If the height of a cylinder is equal to the length of its diameter. Okay. So here's the length of its diameter, and there's the height. We call that x. We call that x. Okay. And it says the curved surface area. So the curved surface area equals 100 pi centimeters squared. And we want to calculate h. Right, well, let's see. So if I was to draw it out like this would be x multiplied by pi, wouldn't it? Okay, because x is the diameter here, multiplied by pi, which will give us the top bit when it's folded out, and this will be x. Okay, so the area of this will be this multiplied by this. So in the first instance we have x multiplied by, we'll do a dot for multiplied by pi, multiplied by another x. Now all this multiplied together will be x multiplied by x multiplied by pi. We don't do this. Why? Because there's a multiplication sign here, so there's no need. Okay. So here's what I have: x by pi, which simplified will be x squared pi. And x squared pi equals, what did they say the curved surface area was? 100 pi centimeters squared. So 100 pi. Now look here, I have two pi's, so I can cancel them. And if x squared equals 100, so we need to square root both sides, and we get x equals 10. So x equals 10 centimeters. So if x equals 10 centimeters, then the height equals 10. Okay? The maths was easy in that, but it was just tricky to get your head around. Right, question 15. Glass of wine is in the form of a hemisphere, radius 4. Find its volume in terms of pi. Okay, that's easy. So, volume of a hemisphere, 2/3 pi r cubed. 2/3 pi r cubed. Let me see. So, just very quickly, if I type all that in, I get 32 and 2/3 pi, 42 2/3 pi centimeters cubed. Okay, 42.666666. Or another way of writing it, if you want, 128 over 3 pi centimeters cubed. So that would work for you also. A full cylindrical container of wine is just sufficient to fill 21 of these glasses. Okay, so if I take this multiplied by 21, I will get the volume of this cylinder container that will hold all that wine, and 21 glasses full of that wine. Okay, so let's do that. 8 divided by 21 equals divided by 3 equals, so it's 896 pi centimeters cubed. It's the volume of that. They said the radius of the base, so the radius here is 8 centimeters, and they want us to find the height. Okay, so we're dealing in volume, so volume of a cylinder, pi r squared h, fill in what we know. We know the volume is 896 pi equals pi multiplied by 8 squared multiplied by the h. 896 pi equals pi multiplied by 8 squared is 64 multiplied by the h. Now we have an equation and get rid of the pi's. That's why I like to leave the pi's, okay, because you can get rid of them if you have one on either side. And this will give us 896 equals 64 multiplied by h. If we divide by 64 on this side, divide by 64 on that side, we'll get 14 equals h. So the height equals 14 centimeters. Okay, so that's 15 done. Okay, 16. 9 solid spheres. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them with radius 1.5 centimeters. Were all dropped into this container filled with water. There they are going in. 1, 2, 3, 4, 5, 6, 7, 8, 9. Water rises, obviously. Okay. They tell us that the radius of this is 3. They want the increase in height. So basically we have these 9, 5, 6, 7, 8, 9 spheres with radius 1.5, and that equals this cylinder shape, okay, which is the same as the rising water, with a radius of 3, but we don't know the height, but we can find it. Okay. Let's get the volume of one of these, then we can multiply it by 9 to get the volume of all of it. So volume equals 4/3 pi r cubed. Volume equals 4/3, we leave it as pi, multiply by pi, multiply by 1.5 cubed. And this will give us volume equals 4.5. Multiply that by 9. The volume of all of this is 40.5 centimeters cubed. And that will equal this cylinder. So we can say the volume of this is 40.5 centimeters cubed. I know the radius is 3. I want to find the height. So I get the volume of a cylinder problem. So volume equals pi r squared h. Fill in what I know. Volume equals, I do know the volume. Oh, sorry. One mistake here I've made. Forgot the pi. I've left my answer in terms of pi. So this is 40.5 pi centimeters cubed. So the volume is 40.5 pi and that equals pi multiplied by the radius squared, which is 3 squared, multiplied by the h. 40.5 pi equals pi multiplied by 9 squared. Sorry, 3 squared is 9 equals h. Cancel the pi's. We divide by 9 on both sides. So 40.5 divided by 9 equals 4.5 equals h. So the height it rose equals 4.5 centimeters. Right, last one, question 17. Question 17, we have, like the shape of a bullet, I guess. So it's a cylinder with a hemisphere on the bottom. And the radius of that cylinder part is 3, which obviously means the radius of the sphere is 3 also, and the total height is 15. So I'm going to divide it into 2 bits. I'm going to divide it into the cylinder here plus the hemisphere at the bottom. Hemisphere at the bottom I know is radius 3. I know the radius of the cylinder is also 3. I don't know the height of the cylinder, but I do know that the height from the top of the cylinder to the bottom of the hemisphere is 15. So if I minus the 3 away this bit here, I know that's the height 12. And it says calculate the volume of the whole container. Right, so we will calculate the volume of this first, then this, and then add them together. Okay, I'm not going to do that for you because there should be no problem in calculating the volume of the cylinder and this hemisphere. But I can tell you when you add them together, you should get 126 pi centimeters cubed. Okay, that's that done, guys. There is one question on the back which I didn't give it to you. It's on page 404. Okay, if you want to have a go at that, feel free to do so. Okay, but it wasn't on your homework, so I hope that helps. Thanks.